Welcome to Module 4, Part 7. In this part, we are going to see the two-terminal MOS structure, that is the capacitor, its biasing, and the energy band diagram. A simple MOS capacitor is made up of the semiconductor substrate over which a silicon dioxide layer is formed. Over that silicon dioxide layer, we have the metal layer. So here is one of the terminal of the capacitor, and at the bottom of the semiconductor substrate we have another terminal. So this black part over here between the insulator and the semiconductor substrate is the junction of the insulator and the semiconductor substrate. Epsilon OX is the permittivity of the oxide, and TOX over here, it is the thickness of the oxide. Aluminum metal is being used to put over this insulator oxide. In some cases, high conductivity polycrystalline silicon is being used. Moving on to the biasing part, consider a two parallel plate capacitor with one end connected to the negative terminal of the battery and the bottom end connected to the positive terminal of the battery. So the end which is connected to the negative terminal of the battery, the negative charges are formed at the top of the plate. At the bottom, we have the positive charges formed at the bottom of the plate. The distance between the two plates, if we consider as d, then epsilon is the permittivity of the free space. Electric field exists between the two parallel plate capacitors. The capacitance per unit area C dash is equal to epsilon by d, where d is the permittivity of this free space and d is the distance between the two parallel plate capacitors and epsilon is the permittivity of the free space. Then the charge per unit area Q dash is equal to C dash into V, where C dash is the capacitance per unit area and V is the voltage applied to this parallel plate capacitor. The prime over here, the dash over here, is per unit area. C dash is capacitance per unit area and Q dash is charge per unit area. Now the electric field E. So the electric field E is equal to V by D, where V is the voltage applied and D is the distance between the two parallel plate capacitor. Consider the parallel plate capacitor with one end of the capacitor connected to the positive terminal of the battery and another end connected to the negative terminal of the battery. Because of this terminal being connected to the negative terminal of the battery, a negative charge exists on the top of this capacitor plate. The electric field will be in the direction towards the semiconductor material. So as a result of which the holes try to move away from this semiconductor substrate into this junction. As the holes move towards the junction, a positive charge will be formed into this junction in between the oxide and the semiconductor substrate. So this is the accumulation of the holes right below the oxide layer, as the electric field direction is towards the oxide layer. More and more holes get accumulated under this particular region. So this is the case of negative biasing when a negative voltage is applied to one of the terminal. The accumulation of the holes take place. Next, consider the case when one of the top plate is connected to the positive terminal of the battery and the bottom plate is connected to the negative terminal of the battery. In this case, the electric field tend to move towards the semiconductor substrate, as a result of which more and more holes move away from this junction. So as the holes move away from the junction, right below the layer of the semiconductor material, a negative charge is formed in this particular region. So this negative charge is nothing but the p type. So it is the induced space of negative charge region right below the junction of the semiconductor and the silicon substrate. So these are the two cases when one of the plate is connected to positive terminal, another plate is connected to the negative terminal, and with this biasing, with this type of biasing, a negative charge is formed right below the oxide layer, and when positive terminal is connected to the bottom plate and negative terminal is connected to the top plate, accumulation of the holes takes place in the junction of the oxide and the substrate material. Thank you.